because I had the part of questions left. So what was left was, so I told you Mill-Thomson formula for this. Okay, this was the Mill-Thomson formula I said, but the problem is this is for Cartesian form, like when it is in x comma y form. But there is no x in this, no y in this. It is only r and theta. Like A is forget about A because A is a constant, but the main important thing is R and theta is the like that is the variable which is being used here. So there is no x and y term here. So this Milne Thomson thing, there is del u by del x and del u by del y. Okay, so this is there actually in this. So the del u by del x and del u by del y, that happens when you have x and y like Cartesian form. But here there is no Cartesian form. There is no x and y. It is in r and theta. So the formula would be different. So what I gave you formula here is, uh, so see, this is what is this basically? Let me tell you. Let me tell you. Okay. So in CR equation, I told you del u by del x equal to del v by del y, and del u by del y equal to minus del v by del x. So what happens is here, del u by del x and this del u by del y, we take these both whatever is in CR equation and we put those in phi 1 and phi 2 two functions, and then we actually put them then integrate them. Okay, because we only have u part and we have to find, so we integrate them. Okay, but here what happens is, like here our in this polar form CR equations also change. So it is del u by del r equal to 1 by r del v by del theta, and del u by del theta equal to minus r del v by del y. So v term we don't have, del v by del r v term we don't have, we only have u terms. So we take u terms, okay, both u terms, del u by del r and del u by del theta, and we put those here. And this is minus I by r because there is r here, 1 by r. And when we take u, minus sign comes, and in v, if v is given, you have to find, then it is just exactly the same, del v by del r. Yo, two people came to the stream. Welcome to the stream, bro. What's up? What is up, folks? Thanks for coming. Really glad to see you all. Welcome to the stream. Yo, Sina Neha AB says, Sinan Hub 3223 says, hi. Yo, hi, what's up? What you doing, bro? Okay. Sinan Hub 3223 says, you know, like she appreciates the work. So thanks for that. I'm really grateful for your kind words, for appreciating my work. I'm really grateful. Thank you very much. So yeah, thanks for the like. So I'm really grateful. Thank you very much for your sweet, kind words. Thanks for appreciating me. So yeah. So if it was about del v, okay. So this was if you had a u function, like we have u function here now. So from u function to find v function, you can do this. This is the formula. And if you have v function and you want to find u function, then e raised to I theta whole bracket, then del v by del r minus it would be, everything would be same, by the way. I by r del v by del theta. Okay, it's exactly the same. So uh, what happens here is, so yeah, because only so there is only theta terms, r and theta terms here, no x and y here. So we would one time do with r, with respect to r we will take derivative, one time we will take derivative with respect to theta. And obviously this is a complex function, so there would be I here definitely. And divided by r would be there uh, because in Cauchy-Riemann function also there is 1 by r, so you have to remember it like that. And this uninvited guest e raised to I theta is there because in like a Cartesian equation we have u equal to x plus iy, and in u we have u is equal to r e raised to I theta. So yeah, so there is so I theta is there. So this I theta is a representation of that, I guess. So we have to carry that. So what we do is after we find this, then we have to integrate. Okay, then we have to integrate. That's how things go in polar form. Okay. So this is kind of complicated. Yo, 28 folks came up. Yo, what's up, man? Thanks for joining the stream, man. For real. Appreciate y'all. Really grateful. Really glad that y'all came. Why not come up in the chats? We can interact, bruh. So yeah. Uh, there is e raised to I theta because there is e raised to I theta here. So and instead of r we are just putting this all. So by the way, this is in Cauchy-Riemann equation also we have del u by del r and del u by del theta, because these are the only two functions we have, r and theta. And one time we take derivative with r, two functions are there, so we have to take derivative with both. So del u by del r, one time we take the derivative with respect to r, and one time uh, we take derivative with respect to theta of u. And obviously I would be there because I is there because like this is complex function. And also there is divided by r because there is 1 by r here in Cauchy-Riemann equation. And minus is there because we are finding v from u. If we've been doing from v to u, this is u to v, like we are finding v from u. If we find u from v, then it would be del v by del r plus I by r del v by del theta into e raised to I theta integration. Okay, so what would happen here is so in this also, this is Cartesian form. So what happens here is also in Cartesian form. Let's say, by the way, this is much more easier form to remember, but actually what happens is, so let me tell you, let's say you this is, by the way, if you have u and you're finding v, this is the formula in Cartesian form. But let me tell you the Cartesian form formula of v. If you have v, you have to find u. Then what would you do? Integration whole bracket. Then so this is the like del u by del x, del v by del y, del u by del y. So but in del v, the first function would be del v by del y, right? Because del v by del y is related. Well, v and y are related because v is the second function of z, imaginary function of z, and y is the imaginary function in v, and second function in v. So v and y are related. They derivative each other with respect to each other. So yeah, this is there. Now del v by del y minus, by the way, plus, del v by del y plus, so whichever other thing is remaining, like I would be there here, whichever other variable is remaining, that would come here in with respect to, which is x and dz. Have fun. So it is totally same with this, right? What do we do here is, because this is like integration, this is so simple function, so you can just break the integration into two parts. Like this is when let me show you. Like let's say uh, when you have let's say integration of f of a whole bracket f of x plus g of x dz, then what you can dx, then what you can do is you can just separate them. Like integration of whole thing of two functions added, it is same as if the functions are separated. Okay, and you just add those separated integrated function. Same stuff. So did you understand? Like, if two functions are added and I take whole integration, it is same as integration of first function separated. Then I add that to the second function separated integration, and it would make the thing. It would give the same stuff. So what we do here is, it is so simple. That's why I just separate this one, take integration. Like, this was u. So for u there was minus. It is always for u you take minus in either it is Cartesian form or polar form. Both have minus. And yeah, this was Cauchy-Riemann equation. This is a different thing. So yeah, in V form you always take plus. Here too, here too. In Cartesian or polar, regardless whatever it is, from V to U, you have to use plus. You have to add this, and I would be there because this is a complex function, and I here it is I, here it is I, but here it is also I, here it is also I, but this is divided by R because in Cauchy Riemann equation you also have 1 by R. So that's how it works. And also uh, so this is integration, added integration. So you can just separate this integration term to these both. But what happens here is there is e raised to I theta outside too. Now you can't just simply, like separate the integration. If you want to do that, you can actually do that, but that would be really troublesome. Why not solve the stuff with this formula and then integrate? So yeah, so I had to tell that in previous stuff. I made that blunder that I gave you this formula to solve, like Cartesian one, but polar form has a separate formula. So I really apologize for that. I deeply apologize for that. So yeah, that's how it works. So so here phi 1 is actually, so here phi 1 phi 2 doesn't work, I guess. Or else you can just say here phi 1 is equal to e raised to I theta. Let's see, del u by del r, del u by del r e raised to I theta, and phi 1, and phi 2 is del u by del theta e raised to I theta. It will give the same stuff. And we are just doing, what we are doing is, so it is just simply f of z is equal to, it is just simply in polar form, what it would be is phi 1 of z comma 0 dz minus 1 I by r, the only difference. And this is, since this is constant, you can take it out sort of. So yeah, that's how it works. Maybe let's say, no man, maybe we can take r here too, but yeah, why not? Let's just do it like that only. So phi 2 z comma 0 dz. So yeah, this is how it works. So let me zoom out, take screenshot or notes or something, because I'm gonna rub all this. Okay, so this is how it is. So I told you, I gave you how to remember this formula. So e raised to I theta is there because in polar form r e raised to I theta u is r e raised to I theta, and you only have u function, so you can only, it only has two variables r and theta, so you can only take derivative with respect to those two variables. So do del u by del r and del u by del theta. That is the only option you have. U always has negative sign in between, and I by r is there because I is there because this is a complex function, and divided by r is there because Cauchy-Riemann function equation also has 1 by r here, and I don't know what else is left. So yeah, one time you divide by del r, and one time you divide by del theta, and also Cauchy-Riemann equation has that. So yeah, this is the only way I can give you to remember this formula. So I also converted this as in this way, like f of z in above stuff, like Cartesian form, same way I did it for polar form. So yeah. Yo, one people came to the stream. What's up? Why not just yap in the chats? Why shouldn't we just interact in the chats? Come on. If you have any doubt, if you want to ask anything, just say it. So yeah, this is the stuff. So one viewer is watching. Thanks for watching. Really appreciate it. Thanks for coming, man. For real. So this is the notes. Please take screenshot. Or yo, 12 people came, bro. 12 folks. What's up? How's your day going, man? Tell something in the comments, bro. Like chat something so we can interact. What's up? Really nice to see y'all. I'm really grateful, man. Really glad to see y'all. What? How you doing, man? You are so chill, folks, man. You all. So why not come up on like chat section and just yeah. So yeah, you have to take screenshot or notes because I'm gonna erase this because I think I have explained the formula till I could have. So like I have not I can't explain it totally from the root because it is kinda like you have to derive it, and now our focus isn't about deriving the formula, it is about use application of the formula. So you just have to remember it. So I gave you how you can remember it, like relating and all that stuff. So try that. And if it is not, you are not being able to remember it, so don't stress, just chill and just keep practicing. You would remember it. That's how remembering works. Yo, 5 people still there, bro. Thanks for staying, for real. Appreciate your visit. And whoever left, have a nice day ahead. Bye. I'm saying bye to the people who left. So you all, not no, I'm not saying bye to you all. So yeah, it would be better. I would be glad if you stay here. It would be fun, right? So yeah. So what we have to do here is for Milne Thompson. First, we have to first let's take so we have u is equal to r plus a square r by r. Cos theta would multiply to both the functions inside because it is out of the bracket simple. Oh, so I had to multiply this first. I blundered. If I was playing chess, then I would have been zero elo because I'm blundering so much. So yeah, like this cos theta multiplied to r is r cos theta. This cos theta multiplied to a square by r is a plus a square by r cos theta. So now what is happening is, uh, this is u, okay. So our next step would be using our formula, okay. So what is our formula is e raised to I theta whole bracket. Yo, 5 people came up. Yo, bro, what's up? Welcome to the stream, man. Thanks for joining. Come on, the chats, bro. Just yap something, like top something in the chat, like we can interact. So e raised to I theta, then we have like where I was. Yes, e raised to I theta del u by del r minus I by r del u by del theta. Now, so for this formula, we have to first find del u by del r and del u by del theta. By the way, this is gonna be useful for us later too. So let's just do it, okay? When we are checking about if this function is analytic, it would be useful then. So because it is also part of the question. By the way, I took your Laplace, like Laplace, if it satisfies the Laplace equation, I took that, and I only have left now analytic, finding analytic if it is analytic function, and to find f of z and v. Okay, so we are in the stage where we are finding f of z and v. So I take del u by del r, so which is equal to del of whole bracket r cos theta plus a square by r cos theta divided by like whole derivative with respect to r. So what does with respect to r means? Like r is the only variable which we are gonna differentiate, right? Like which we are gonna differentiate. So r is the only variable we are gonna differentiate. So yo, one people came to the stream. Yo, what's up, bro? What's up? Thanks for coming. Thanks, John and bro. Really grateful that it came. Glad to see you here. Why not come up in the chat section and just whatever you feel like, say it out or not. So yeah. So what with respect to r derivative means that r will be only considered variable which should be differentiated. Others would be either considered constant, so derivative would be 0, like d by dx equal to 0, or coefficient, okay, or it can be coefficient. Yo, two people came up. What's up? Welcome to the stream. Thanks for joining, man. Thanks for joining. Really appreciate it. Oh, so they left. Have a nice day ahead. Bye. So yeah, I guess they left. So coefficient when it is multiplied or divided to r terms, okay, like they are joined, they are joined, right? Wait a second, I need my gloves right now because locate is humid, like summer season, bro. So once it is humid, this board is gonna like start to tweaking. Like this board is gonna be crazy. Like this board is gonna get cooked, bro, for real. Yo, wait a second. Let me grab my gloves. No. Ouch. Okay. It's kinda tough to wear gloves with one hand. But yeah. You can do this. Yeah, hey. Wait a second. Wait for me a bit. Yeah, so now it's here. Now we are here. Yeah. Yo, what's up? One person came to the stream, bro. Let's go. Welcome to the stream, man. Thanks for coming. Okay, he left. Bye. Nice day. Have a nice day ahead. So we have so other other than r, other variables would be considered either constant if they are standalone, constant if alone, and if they are like multiplied or divided to r term or joined, then it would be like dk f of x by dx, or derivative of constant is equal to, like constant you have to take out, then you have to just multiply it later with the derivative of the function whichever we are having, like k df of x by dx. Okay, simple stuff. So now what we have here is uh okay, so what we have here is now what we have here, this function, we would just now do this. Like I have explained you what's gonna happen now. Okay, what we're gonna do. So in r cos theta, only r is the r term, right? So this is gonna be considered variable and differentiated. But cos theta is theta term. It is not r term. It is different than r term. So it would be either considered constant or coefficient. Is it alone? No. It is actually multiplied and joined to r, this cos theta. Then what it would be considered coefficient. So its derivative won't be 0. It would be considered coefficient, like it is multiplied or divided to the r term. Like this is r term, this is multiplied to it. So yeah, so it is coefficient. In coefficient we just take out coefficient and take derivative of the variable, and we later just multiply blindly, like as it is, multiply the coefficient we took out to the like variable. Okay, like after differentiated. Okay, so what we do here is I would take this cos theta out. Cos theta would be out. I would take derivative of r, derivative of r by derivative of r. Since it is also looking same things getting divided, it is already 1, but let me show you why it is 1. It is not because they are same thing, but let me show you. Like r raised to nothing is there, so r raised to 1. Now derivative of x raised to n function is n x raised to n minus 1. So what happens is here, whatever raised to function is, the number is there, that is the n. So that n gets operated. So what happens to the n is the raised to stuff comes in the power comes in the coefficient, and that power is reduced by 1. So here the raised to thing is 1, nothing was there, so it is 1. Where it is, yeah, nothing was there, and r raised to, so it is 1. So this 1 is raised to thing, so it is the power, so it is n. Now this n comes in coefficient, nx raised to n minus 1, so this power also gets reduced by 1. So 1 minus 1 is 0. Anything raised to 0, like let me show you, anything raised to 0 is equal to 1. So 1 raised to 0 is 1, 1 into 1 is 1, so 1 into 1 is 1. So this term is 1, like like this del r by del r is 1, right? And 1 into anything is 1, so nothing changes, so it is cos theta. Plus now what happens is now so what happens is here 1 by r, so this is 1 by r actually, right? See, let me show you. When r is multiplied, and if r is divided, r divided can be also written as 1 by r multiplied, because r is opposite of 1 by r, opposite, okay? R is opposite of 1 by r, okay, in fraction wise. Numerator became denominator and all that, right? So when you are multiplying opposite stuff, then it is similar to the division, because division is the opposite of multiplication, and you are just taking opposite fraction. This is actually r by 1, right? R below nothing means r by 1, like you are taking everything what they have. So it was one piece, there was no division of it. Denominator says what you have, denominator says total thing, r numerator says what you have. So from one thing I take r times of that thing, so that is whole number. Like I take whole thing this amount of times, like there is no division, there is no part of this, no fraction of this, but it is one piece, I take some multiples of it, so that is like whole numbers, right? So this is a whole number, so it is r multiplied by r by 1. So nothing is there, so divided by 1. So r by 1 is opposite of 1 by r, right? So since it is multiplication, this is division. Division is opposite to multiplication. So we want to multiply, so we want to multiply this division. Okay, so this is multiplication, this is division, and we want that division in multiplication form. So what do we do is, okay, uh so division is opposite of multiplication, so to balance that opposite, we just reverse the fraction of here. So we take the opposite fraction, so that balances and justifies our division into even if we do that, write that as multiplication, because that division opposite of multiplication is catered by our fraction which is opposite of the previous fraction. So that's how I made divided by r as 1 by r multiplied by a square cos theta. Now, what is a square cos theta? These two are different from r, right? So what did I say? Derivative is with respect to r means r is only the variable which would be differentiated. R is here, it would be only be differentiated. This r would be only differentiated, these two won't. So these two would be the treated, these are other variables than r. So these other variables would be either be constant if they are alone. Are they alone? No. So they are multiplied or divided with the r term. Here is the r term, they are multiplied to it. So, or divided to it, same thing. 1 by r multiplied and r divided, same thing. So uh so they are multiplied or divided to the r, so they are joined in the same term, so they are treated as coefficients. Okay, there are other terms, so they are treated as coefficients. In coefficient, we just take the coefficient out randomly, we took out coefficient, and we take derivative of this, and then we multiply this directly out to the derivation of this. Now what is this? This is r raised to minus 1, 1 by r, because I told you that power says how many times, okay, a times. Yo, what's up? One people came to the stream. Yo, welcome to the stream, man. What? Okay, he just left. Have a nice day ahead. Bye. So, yeah, how many times itself gets multiplied, right? Like power means that how many times itself it gets multiplied. Now, what do we do here is, one is like raised to power is like how many times, like which we write in superscript here. That means how many times itself it gets multiplied. So if I put minus here, this is opposite sign. So something opposite is gonna happen. So opposite of multiplication. What is opposite of multiplication? So it is division. So division. Now division, when we convert into multiplication, we reverse the fraction to balance it. Reverse to opposite fraction. Okay. Now numerator to denominator exchanges. Okay. So this is actually like so let me tell you. So this r is actually raised to 1. Now this is actually r by 1, because like you have this total, you took multiples of it, right? Numerator is how many you take, like numerator is how many stuff you take from the total stuff, like how many times it divided, total divisions. Okay, denominator shows total divisions and numerator shows how many you took. So you took multiples of it, because division was 1, there was no division, it was a total piece. Okay, so now it is r by 1. What would be opposite? 1 by r, simple. So this is 1 by r, where it is. So r raised to minus 1 is 1 by r. So we wrote 1 by r as r raised to minus 1. Now we have to take derivative. Now derivative, r raised to minus 1, derivative. What it is? Nx raised to n minus 1. So n is whatever is in raised to power that we consider as n. What is here in raised to power? Minus 1, that we consider as n. Right. Now when we consider this as n, so what happens is here, this is raised to n here. So what we do is, this raised to n thing comes in coefficient and it reduces itself by 1. So this is the power here raised to, this is n minus 1, so minus 1 comes in coefficient, like this is minus 1 and 1 into anything is that only, so only minus sign would be there. Yo, one person came and left the stream. Thanks for coming. Have a nice day. See ya, bye. So yeah, so 1 comes in coefficient and 1 that this power also reduces by 1, so minus 1 minus 1. So same signs increase, but with the sign, same sign increase with that sign I've added. Okay, so now we just have to take this minus sign outside, this is common, like then we just divide this by minus these both terms, because after this we can multiply to these both and it's gonna come same, because it is out of bracket. So if this was minus, this was minus, I divided by minus, minus divided by minus, same sign divide, it becomes plus, this also become plus, so the 1 plus 1, so same sign anyways was increasing when added, so yeah, and gets added, so 1 plus 1 is 2, so this is raised to minus 2. So what we do is, wait a second, minus r raised to minus 2, simple, we got this. Okay, del u by del r. Okay, so now I have filled my board somehow. I might erase this. Okay, let's just do del u by del theta, then I would erase, I guess, you know. Yeah, so let's go with that. So del u by del theta, I just have to take the same function which you have here, which is r cos theta plus a square by r cos theta. So r cos theta plus a square by r cos theta del r. Okay, oh sorry, del theta. So now what would happen is del theta is in denominator, so we are differentiating with respect to theta, which means theta is getting differentiated or derivated. Others would be either constant if alone derivative would be 0. Okay, or maybe others can be coefficient if multiplied or divided with like they are some times of that theta, or they are some like they are joined to the theta, like they are one term with the theta, right? So they are part of theta, right? So multiplied or divided with theta function. So when they are multiplied or divided with theta function, so this would be, their derivative would be, so just take the coefficient out, then take derivative of the function you want, then uh, just multiply after derivating the function, just directly multiply that coefficient to it. Okay, your work is done. Yo, what's up? One person came to the stream. Yo, welcome to the stream, thanks for joining. What's up? Come in the chat, bro, we can just interact. That'd be cool, you know. Okay, bye, thanks for coming by, thanks for passing by. Have a nice day ahead. Bye. So yeah, d by dx of k of f of x is equal to k df of x by dx. So this is how it is. Okay, this is how it is. So yeah, so now where will we? Yeah, so r is other term than theta. This is either constant. Is it alone? No, it is not alone, so its derivative won't be 0, so it is not constant, it is coefficient, because it is multiplied or divided with the theta term, cos theta, right? Theta is there, theta is also in the denominator with respect to which we are doing, so theta is the variable we want to differentiate, so we have that, it is multiplied with it, so it is 1 with it, like plus minus separate terms, multiply and division, join terms. Okay, they are considered in one term only. Okay, so you got that. So this is multiplied to cos theta, so this is in that term only, so this is coefficient, not constant, so its derivative would be, we would just take that coefficient out, take derivative of our function, and just directly multiply it after we have took derivative of the function, that result we would multiply it with the coefficient. So what we do here is r, we take it out, we would take derivative of cos theta, so I would have to give you a formula, d by dx of cos theta, so derivative of cos theta is equal to minus sine theta. So derivative of cos theta is minus sine theta. So what I would do is here, so r I took out, did derivative of cos theta, which is minus sine theta, minus multiply, so r would be multiplied later on, so r will be also multiplied by minus, so it would be minus r sine theta plus, now a and r square, a square and r both are different than theta. A square and r both are different from theta. Okay, they are not theta terms, so they are either constants. Are they alone? No, so their derivative won't be zero. They are with theta function, yeah, cos theta. They are with cos theta, so they are coefficient because they are multiplied with theta function. Which theta function we are gonna take derivative? Okay, so if they are multiplied with it in single term, so what we do is here, for derivative we would take that constant out, coefficient out, and we would multiply that coefficient after we have taken derivative of the function. Okay, we have taken the derivative of the function, then that to that result we would multiply the coefficient directly. So we would take a square by r out, then a derivative of cos theta, told you, minus sine theta. Do minus sine theta, multiply it. Okay, now what would happen here is minus, multiply to this plus, or let me show you, minus to minus and plus into plus is equal to plus, minus into plus, or otherwise is minus. Okay, like charges multiplied gives positive, unlike charges multiplied gives negative. Simple. So what would happen is here, this would be negative, right? Yeah, and I multiplied that minus there, so here we don't need minus. So what we have here is minus r sine theta minus a square by r sine theta. This is what we have now. Now we can put this in this formula. So let's just do it. What are we waiting for? E raised to I theta is a constant fixed stuff. Now u by r, del u by del r, do we have it? Yeah, we have it though. Yeah, cos theta minus r. Okay, cos theta minus a square cos theta by r square. Cos theta minus a square cos theta by r square. See, yo, one person came to the stream. Welcome to the stream, bro. Thanks for joining. What's up, bro? And he left. Thanks for coming. Bye. Bye. Have a nice day. So yeah, r raised to minus 2, I said you that when raised to shows multiplication, but when it has opposite sign minus, it means opposite of multiplication. It will become division. Okay, division of that many r with itself. Okay, because power is multiplication of r with itself that many times. So here r square. So yeah, 2 times r will be multiplied to itself. But let's just keep it r square. Okay, for our simplification, isn't it? Now plus minus I by r. Okay, minus I by r del u by del theta. Do we have that? Yeah, we just now found out. Minus r sine theta. Wait a second. Whole bracket minus r sine theta minus a square by r sine theta. Yeah, hey, that's cool, I guess. Now what would happen here is this r multiplies inside to both, like divides inside by both. So when r is divided by r, it gets cancelled because they are same and opposite. Same number getting divided r and r. so they cancel each other to 1, and here it becomes r square, like it multiplies both, like divides both. Okay, so because here there is another r, so it gets 2 times r is getting multiplied to itself, and power says how many times it's getting multiplied to itself. So it's getting multiplied to itself 2 times, so r square, simple. So r square, now what we have here is, this is minus. Okay, I let's multiply this whole term with minus, so it will be same because minus is taken common out. Okay, so minus multiply minus is plus, minus multiply minus is plus, minus multiply minus is plus, same charge multiplied, same sign multiplied is plus, minus minus plus. Okay, minus minus, two same signs multiplied plus. So now what is happening here is another bracket, by the way. Okay, now it is kind of problematic, isn't it? Okay, so I would zoom out, take screenshot or notes, then I would erase the whole thing. Then we would go proceed further because I have no space in the board and things are getting complicated more and more. So, can you see the board? Wait a second. Can you? Can you see the board? Yo, what's up? Welcome to the stream. Thanks for coming. Appreciate your visit. Why not come up in the chat section? We can just interact. So yeah, take screenshot or notes. This is the notes, and I would erase it so that I can explain further. So let me show you close up. I'll give you close up of the notes. If anything you have doubt or anything you want to tell, anything you want to yap, you can do it in chat section. Chat section is open for you all. So now I would erase this because I have to, we have to do this because, so yeah, we have to do this, right? But wait a second, this can be actually a bit different. Wait a second, this can be much more easier. I guess I have to do something else. Okay, I'm erasing this. Okay, I guess you have taken screenshots and all that stuff. We have found our formula stuff, whatever we needed, so we just have to check up with it. Now what we need is, here we go. So we found this here. Okay, e raised to I theta cos theta minus a square cos theta by r square plus I sin theta plus I a square by r square sin theta. Does this strike anything to you? Does this ring a bell in your head? Wait a second, let me simplify it for you, then it would, definitely. Or else you are just joking. So if you have ever studied So if you have studied harmonic functions, there is actually a formula: e raised to I theta equal to cos theta plus I sin theta. I guess this is the Moore equation, but yeah, like e raised to I theta is cos theta plus I sin theta, right? Because by cos e raised to n theta is equal to something e cos n theta plus I sin n theta, something like that. Okay. So in harmonic functions, if you want these notes of harmonic functions, then it is in my threads, which is at the rate big brother 4644. So yeah, you can find the notes there, but you only require this formula here, so you don't need to even wrap your head around that much. But if you do, then it's better for you, maybe. Yeah. So this is the formula: e raised to I theta equal to cos theta plus I sin theta. Okay, because this I here in the imaginary function would come here in the imaginary function I, and cos theta is our real function, so no I. So what I did here is I just arranged the terms cos theta plus I sin theta, and I just took the minus sign out, and a square cos theta by r square and a square sin theta by r square. Do you think something is common? Obviously, a square by r square here and a square by r square here is same. We can take it out common. Like after that, it would be multiplied to both. Like we are dividing it by both and taking it out, so it is just same thing. Okay, but easier to solve. Okay. So, but this one has I extra, so I kept I sin theta is there only. If we remove this and remove this and common take it out, like common from it take it out, we can multiply it to both of them. So if I take it out, what it becomes is this: there is cos theta remaining, there is I and sin theta remaining. So I put this here. And by the way, this would have been sin theta has positive sign, and cos theta is negative sign, right? So to make cos theta positive, to look similar like this, to make cos theta positive, I actually took minus sign out too. So this was actually plus, so I took minus sign out, so I can multiply this 2 with minus. So what I had is actually cos thing was having negative sign, sin thing had a positive sign, but when I multiply it with minus, I took out minus, so I divide both by minus. Minus divided by minus, same stuff, dividing getting positive, and opposite, like plus getting divided by minus, opposite signs divided gives you negative. So this is like this. And also another formula: e raised to minus I theta is equal to cos theta minus I sin theta. Only this thing changed because this changed. Imaginary part is changing. This is actually called conjugate. This is conjugate of this. Okay, like their imaginary part or I part is changing sign, opposite sign. Okay, so now what I would do is here e raised to I theta whole bracket. So this is cos theta plus I sin theta. This stuff, what is it? E raised to I theta. E raised to I theta minus a square by r okay, a square by r square e raised to minus I theta. Simple. E raised to minus I theta, isn't it? Cos theta minus I sin theta. Cos theta minus I sin theta is e raised to minus I theta. So this is e raised to minus I theta. So what did I do here is, now this will multiply to both. So when we have same base a raised to m into a raised to n, since this says how many times multiply, so since base is same, so we can do is a raised to m plus n equal. Okay, these are equal. A raised to m into a raised to n, bases are same, indexes are different, so we can do a raised to m plus a raised to n. Okay, since this says how many times it multiplies to itself, so we can just add them and we can find like total multiplication how many times it would do. because multiplication is repeated addition, so we are going reverse. This is repeated multiplication, so we are going addition because this shows how many times is multiplying, right? So what do we do here is just remember this formula, okay? If you didn't understood what I said, because I might have made it complicated, but yeah. So you can just understand this, right? Right. A raised to m into a raised to n, when bases are same, indices are different, it is getting multiplied. Just add it because multiplication is related to addition, right? So let's just do that, okay? So, like, let me show you. R square into R cube is gonna be, let me expand this. R into R is R square into R into R into R. This is 3 times R, this is 2 times R. Now, by the way, if we do this here, R2 plus 3, because they are just adding the number of, like, if I'm more increasing times of itself multiplying, which is actually increasing power. That's why power increases, okay? Like the more times I multiply itself, so I increase the number of times it multiplies itself, which is actually increasing power. So I increased my power here. That's how it happens, okay? So, and since if I have a raised to m and a raised to n, addition is opposite of subtraction, and multiplication is opposite of division. So we are doing opposite things to make it balanced. Same thing goes by division, because division is repeated subtraction, okay? Division is repeated subtraction, multiplication is repeat addition. You have to always remember that. Integration is finding area under the curve, and derivative is rate of change, okay? Yeah. Now what do we do here is, so e raised to I theta into e raised to I theta. So what would be this? E raised, so I showed you here, multiplied same things base, index different, so add the indices. Adding the indices, now what happens here is minus a square by r square e raised to minus I theta, e raised to minus I theta into e raised to I theta into e raised to I theta. So what do we do here is, I told you, like, same base. So wait a second, let me tell you. Like, what I told you is here, r raised to minus 1 is equal to 1 by r. Why? Because because r raised to 1 means times multiplied, opposite of 1 is minus 1, so minus is opposite sign, right? Now what is multiplication's opposite? Times, it is divided. Opposite of multiplication is division, so it is amount of time it is divided. So when it's divided, I can write division, like I'm taking multiples of the r, okay? Like I am taking r multiple of 1, okay? R multiples of 1 I take, okay? This means denominator is total thing and numerator is what I take, how many parts of it. Okay, parts. So when I like r by 1 means how like r numerator means how many parts I take, and denominator means how many parts it was divided total. So it was not divided, it was 1. So I take r multiples of it. Okay, so when r by 1, so when I reverse that fraction, which is 1 by r, exchange numerator and denominator. Okay, wait a second, exchange numerator and denominator. I exchange the numerator and denominator. So this is opposite fraction of this, r by 1. R by 1 is opposite fraction of 1 by r. Okay, so it created opposite. Okay, and I had I had to divide by r. So divide by r is equal to multiplying by 1 by r, because it is opposite. 1 by r is opposite fraction of r by 1. So multiplying that is doing division by r, because division by r was opposite of multiplying by r. So this balance the opposite. So opposite fraction balance the opposite of multiplication, which was division. So I can write multiplying by r, dividing by r as 1 by r, multiplying 1 by r. So what I did here is e raised to minus I theta means I am dividing by e raised to I theta. So what here would happen is e raised to I theta is getting divided by e raised to I theta. Same stuff divided equal to 1, because 1 multiplied by stuff would be same stuff, same. This only tells like like multiplying by this, what would give this only tells division. Division tells that only. So if same stuff we are finding when we multiply by 1, so when we divide same stuff it would be 1, right? So also everything is a factor of itself, right? You have to remember this, everything is factor of itself. So it would just cut 1. So and here, so this is 1 into I theta, 1 into I theta. When there are same stuff, we take it a common I theta, and we add 1 plus 1, which is 2. So it is e raised to 2I theta. Okay, e raised to 2I theta, and this is minus a by r square. Now what happened is, in Milne-Thomson we had to take z as sorry, r as z, and theta as 0. Okay, now what happened here is, now in this equation if I take r as z, then it would be z square, right? Z square, and e raised to 2I theta, if I take it 0, like wait a second, multiply by 0, wait a second, let's just keep it as it is, theta, this is r square. So now I would write it again. So e raised to 0 would be e raised to 0, like 0 into anything is 0. Okay, so like if I take, like there are 1,000 things, if I take nothing out, like nothing multiple of it, taking nothing of it, then I would have nothing anyways, if even if 1,000 things are there. Okay, so it is e raised to 0, like this means how many times, right? How many time added, how many times added. I didn't add it only, like I have added it none times, so it is not added only, nothingness is still there. At the start of the word there is nothingness, then we add something, but I didn't add anything, I added 0 times, no times, then nothing is added, it is 0. So yeah, that's how we can explain this. Okay, So e raised to 0. So e raised to 2 into I into 0 is 0. E raised to 0, anything raised to 0 is 1. Now e raised to 0 is 1 minus a by a square by z square, because r is supposed to be z. Okay, so 1 minus a square by z square. Now what we would do is, in Milne Thomson we take integration of 1 minus a square by z square dz. Let's go. Now we're talking, bro. Milne Thomson stuff. Wait a second. Should we take it like this? Where did I vanish, bro? Like, where did I vanish? What? What? Okay. So, I got stuck again. Yay. So, what now? Let's forget it. So, integration of x raised to n is equal to x raised to n plus 1 by n plus 1. So famously say integration is antiderivative, so it is opposite of derivative. In derivative we reduce power, in integration we increase power. In derivative we multiply the power, in integration we divide the power. Okay, here it is x raised to n plus 1 by n plus 1. So this is 1 raised to so 1 means what is 1? Z raised to 0. Anything raised to 0 is 1, right? So this is z raised to 0 is also 1. So let's put 1 z raised to 0 in one place. So now what would happen? We would do like this is raised to thing, right? 0. So here raised to thing is n, here raised to thing is 0. So 0 is the n. So what we do is we divide it by 0 plus 1. We raised to thing is divided by plus 1. So raised to thing is 0, 0 plus 1 we divide, and exponent is also added by 1. So 0 plus 1. So this is z by 1. Z by 1 is z. Okay, simple stuff. Z by 1 is z. Now minus a square. Z square means z raised to minus 2, because raised to says how many times we multiply, and minus is opposite sign, it says opposite of multiplication, which is division, like how many times we divide, and we divide here by z square. So it is z raised to minus 2, because we are dividing instead of multiplying. So we are doing same amount of time two times, so 2 remains. But what we are doing, instead of multiplication we are dividing, so we are doing opposite things. So if we are bringing it to the multiply side, then we would balance it by doing opposite thing, which is minus sign, opposite sign. Okay, now a is a for dz, z is variable, other coefficient. Okay, coefficient. Okay, so z raised to minus 2 is our coefficient. Okay, so what I would do is z raised to minus 2 is our coefficient. So z raised to minus 2 is our coefficient. Sorry, a square is our coefficient. So what do we do with coefficient? Did I write it? No, I have to write it again. So d k into f of x. So f of x is our function, k is a constant. So in that case we take k out, constant out, that take derivative of our function, and multiply that answer directly with k, our constant. Okay, so a square is taken out, z square integration we take. So z square integration would be minus 2 plus 1, like minus 2 was the raised to thing there, and here raised to thing is n. So minus 2 is the n, and what do we do with n? Raised to thing we take it down, like divide it with its plus 1. So We took that minus 2, divided it with plus 1, and we also add plus 1 to that power itself. Plus 1. Minus 2 plus 1, opposite sign. So they would reduce each other. 2 minus 1 is 1. But since minus 2 is the greater thing with minus sign, so minus sign survives because greater thing survives more. And here also minus 1. Right. So here we are. So this minus would make plus. Okay. So this is z plus a square by z. Yo, what's up? And z raised to minus 1 is obviously z divided by z. Okay. Z raised to minus 1. So raised to is raised to says multiplication. If you are giving opposite sign, it means opposite thing of multiplication. So multiplication opposite thing is division, so it means division. So divided z. Now I guess, okay. So I guess, wait a second. What did we do there right now? Wait a second. We did ignore something. Right. We actually ignored something. Why I feel like we ignored something. Okay, there is supposed to be minus I by r. Yeah, and I ate up that. Oh yeah, we multiplied I by r inside, but yeah, we multiply by c. In I luckily I kept this. Okay, we multiplied r inside, but we didn't do anything with I. So it was plus I. Okay, so what? Okay, it later became minus. Now it became plus. So, but I was still intact. And in integration, we take I out. So anyway, I would be there. So voila. So this is some z function, I guess. Whoa. Okay. So is this supposed to be a function? I don't know. What is it supposed to be? I'm really confused right now. So we got I a square by z, but we have u and v though. Let me just zoom out. You just take screenshot and notes. Then I would erase all of this. Did you take screenshot and notes? Wait a second. Well, what? Okay. Okay. Here we go. I guess you have taken screenshot and notes. I would erase all this. Okay. And I would supposedly keep this power, I guess. But the problem is if I the f of z I found, what I would do of it, like what I would do of it for real. I mean, okay, yeah, I can substitute it back. I forgot about that for real. But like what? Okay, I'll just do that. Right? I'll do that. Why not? Why not, bro? Like why not? So we have done Mel Thompson. I hope you have taken everything notes. So, oh boy, there is so much to cover and so less time, bro. Like crazy, bro. So less time, bro. Time is crazy, bro. Like what? It's just running at the wrong time, bro. Time is running at the wrong time, bruh. Blah. Brah. Here we go. Now what we would do is, since z equal to in polar form z equal to r raised to I theta, I told you, I guess. So we have function z plus I a square by z. Now what I would do is re raised to I theta plus I, what? Why? Like, why we are putting this again? Why we are putting this again, bro? Like, This is painful, man. This is really painful. We have to put this stuff again. Like, why do we need to do that? Okay, bro. Like, I don't get it. E raised to 2i theta. Did I do e raised to 2i theta? I forgot that, right? No, I did it. Yeah. Yo, two people came to the stream. Welcome to the stream, bro. Thanks for coming. Yeah, they left. Thank you for coming. Have a nice day. So yeah. Uh what I do is here is a square by r e raised to I theta is I guess so this should be like what it be. So by the way, I forgot about CR equation. CR equation here would be del u by del c del r equal to 1 by r uh, del v by del theta, and when we exchange the denominators, oh sorry, here u, so when we exchange the denominators like with respect to differentiation, so it becomes opposite, so we put minus sign, which is also, which minus sign always shows opposite things. This is called opposite sign, so we put opposite sign here. And opposite of division is multiplication. Opposite sign, like here it was positive. Opposite sign, uh, multiplication is opposite of division. So multiplication is opposite of division, so multiplication is opposite of division, so yeah, so we did opposite thing here, and we did opposite sign, which is minus. Here it is plus, and we also do del v by del r, and here sign with respect to thing was exchanged denominators. So that was so we took opposite denominators, we exchanged denominators, so we balanced it by doing opposite thing with r. Like 1 by r was done r, like multiplication and division were opposite, and opposite sign, which is plus to minus, we converted that. So you can remember it like this, and now we have to compare our function with this, which is kinda different, because I don't know if this complicated function would be doing derivative stuff, but yeah, let's try. By the way, right, f of z equal to u plus iv. So I stuff is after I whatever it comes is v, and u is the real part without the I thingy. Here u would be our this part, and since I is here, so v would be this part. Simple stuff, I guess. Okay. I guess we can just take r e raised to I theta part out. Maybe. But can we? But would it make any difference? Like, yeah. That is kind of complicated, but yeah, whatever. Let's go. I'm kind of confused right now what we should do or not. But yeah, let's just give it a try. Why not? Wait a second. No, not this part. So I have to take only this, okay? No issue, I guess. So we have to find this separately. You have to understand this. This part is V, this part is U. You remember, right? So yeah, I'm calculating with that, I guess. So yeah, I guess I have explained you earlier like what are the division principles of this derivative, but still let's try this. When we are taking derivative of with respect to r in denominator, r is differentiated, others are taken as constant if alone, if multiplied or divided with r, if multiplied or divided with r, we take it as coefficient. Oh boy, okay. I'm kind of feeling tired. I don't know why, but yeah, sorry for that. So yeah, if r it is differentiated other variable, it is either constant if it is alone, and if it is multiplied with r, it is coefficient. Okay. And another thing I had to say, dy dx of k of f of x, is it is equal to k into dy dx of f of x. So what happens here is, if you take derivative of constant with function, then you take out the constant and you multiply it with the derivative of the function answer, then you multiply that the constant with that, uh, then what we do is what we do is uh, k df of x dx. Okay, yeah. So this is how we do it. And by the way, derivative of sole constant is actually 0, and I guess yeah, we might need this. Dx raised to n is equal to derivative of x raised to n is nx raised to n minus 1. Simple. Yeah. Now what we do is, so there is our function r e raised to I theta. For that, what we have is e raised to I theta. So this is different from r. This is not r function, this is theta function. But is it so other what we call, if considered constant if alone, are they alone? No. So they are multiplied or divided with r term. This is r term multiplied. So this is coefficient. What do we do with coefficient? Keep it out. Take derivative of our function, which is r, and then multiply that constant coefficient with that. Then what would happen is uh, r del r by del r. I hope you understand what this means, right? Same stuff getting divided. Or let's say, even if we go with the rule of derivatives, r raised to 1 derivative would be, by an x raised to n minus 1 rule, we take the exponent raised stuff in coefficient and reduce its power. So this is r raised to nothing, so r raised to 1. So we take this raised to 1 power in coefficient and we reduce its power by 1. So 1 minus 1 is 0. Anything raised to 0 is equal to 1. So this raised to 0, wait a second. Focus is gone. Yeah, r raised to 0 is 1. 1 into 1 is 1. And 1 is to, so anything, so this is 1, by the way, okay? This is 1. And what we had outside to multiply e raised to I theta, this was coefficient. So 1 into e raised to I theta would be e raised to I theta, because anything multiplied by 1, it is itself, because 1 is multiplicative identity. Okay, this is multiplicative identity. Simple stuff. Now what happens is, oh my god, I'm kind of tired. Okay, sorry, I'm not complaining, I'm sorry, I'm not blaming, I'm just, I'm just talking to myself or something. Yeah, just I guess pain is coming out from the mouth somehow. unwantedly or something. Yeah, involuntarily. Yeah, I'm saying that. So yeah, so e raised to I theta it is. What would be happening here? R would be the coefficient here because, okay, I have to explain you again from theta perspective. So I have this theta, let's take it down. This theta means uh theta stuff would be differentiated, other stuff are constant alone, okay, and wait a second, yeah, other stuff are constant alone. Wait a second, did your Cauchy Riemann Cauchy Riemann, did I made your revision? Did your revision? Yeah, I did. So constant if they are alone, coefficient if they are multiplied or divided with sorry for the cough. So coefficient when they are multiplied or divided with theta, right? So e raised to I theta is theta term. It is going to be differentiated. R is different from theta, so it is either taken as constant or coefficient, right? Is it alone? No, it is not alone. It is, so it won't be like constant. So it would be coefficient because it is multiplied or divided with theta. Multiplied or divided. It is multiplied with e raised to I theta. Theta term. It is multiplied. So it would be considered as coefficient. What do we do with coefficient? Take it out. Take derivative of your function. Then directly multiply the constant. Simple stuff. So what I do here is I take r outside. Then put e raised to I theta. So we have e raised to I theta here. So derivative of, oh boy, I have to tell you function chain rule too. Okay, wait a second then. Okay, so when u is equal to f of x, then d f of u by dx is equal to df of u by dx. Then this should be dx because this should be f of x, right? Because this is of derivative of with respect to x. But since u is a f of x, so we can still differentiate it, okay? F of x, but it is inside. So we have to extract that f of x. Now we did this became, now it is extracted. Now inside there is f of x. Now we would do df of x and multiply it with df of x by dx, okay? Now this is the chain rule. If this was integration of f of u would have been integration of f of u would have been integration of f of u, okay, divided by integration of f of x. That's how it would have been dx, okay? So because this is antiderivative, integration is, so that's how it works. But what we have here is e raised to I theta. By the way, d by dx of e raised to x is stays same. E raised to x, it would be e raised to I theta. So what did I tell you in chain rule? So it should we should have function of theta, but we have function of I theta now. So I theta is a function of theta, but we have function of something, and that is a function of theta. So this is inside like nested thing. Like, yo, one people came to stream. Yo, welcome to the stream, bro. Thanks for coming. Really appreciate a visit. Really, bro. I'm really glad that you're here. Look, come on, bro. Come on in the chat section and we can yap, bro. For real. Okay. Have a nice day. I guess he left. Bye. See ya. So yeah. R e raised to I theta what happens is in r e raised to I theta. So first is the function is exponent of something. Okay, exponent of I theta. So it is of I theta's function, not theta's function. E raised to theta would have been, it would have been crazy. It would have been cool. But it is e raised to I theta. It is exponential function of I theta. Now I theta is a function of theta. I theta, this is a function, like this is a function. Now this is a separate function. This is what we want. Now this is a nested function, right? So I theta is a separate function whose exponential e function we have. So theta is what we want. It is inside I theta function, and I theta function itself is inside exponential function. So it is a layer by layer, double layer function. Double layer function. Now what it means is, so now we would use chain rule, df of u by dx into df of x by dx. Now what I would do is, I did, like, regardless of anything, I took derivative of this. Okay, like they told you, like this function, take its derivative as it is, then multiply with as it is function. Okay, this is inside function. You have to take derivative with respect to that, but this is a function as it is. First you have to take derivative, then inside you have to break it, and inside function you have to take derivative. First outside function as it is derivative you have to take, then break it, then inside function derivative you have to take. And that's how we get is, first is e raised to I theta, then e raised to I theta derivative is e raised to I theta. I took that derivative overall. Now inside function is I theta, I have to take derivative of that. I is a constant, then I is a constant, it would be taken outside. Like I told you, constant, like I is a root 1, it is a number, it is not a variable from the start only. So in coefficient you have to take coefficient out and take derivative of function, then multiply it with the coefficient directly. So I had taken out derivative of theta by theta, like it is 1, like same thing getting divided, you can already say this is 1. What I would explain you, theta raised to 1, and dx raised to n is n x raised to n minus 1. So x raised to n is raised to thing is n, so raised to thing is here 1, so 1 is n. So we take this raised to thing in coefficient, nx raised to n minus 1, so we reduce this power by 1, which is what we did here, nx raised to n minus 1, that power. Okay, so 1 minus 1 is 0, anything raised to 0 is 1, this is 1, 1 into 1 is 1, like I told you, anything multiplied by 1 is 1, that itself. So 1 into 1 is 1, and 1 into 1 is anything is itself. So re raised to I theta into I into 1 would be that only. So we found this. Now what do we do is, even if we prove this is equal, then it is equal. So is it equal? Wait a second, these are different. Okay, I found different stuff. So similarly, I hope you understand this too, like we are, so r would be, we would take derivative, so r raised to minus 1, so this is r. So just remember this. Okay, uh, so forget it. Okay, let's just do it with our style. So this is, so I told you in in with respect to del r, if you do derivative, so r would be differentiated, other would be treated as constant if alone, and coefficient if multiplied with r. So a square by I e raised to I theta, This is theta function, this is something a constant. So are these r? No. Are these with respect to r? No. Are these r? No. So they would be either constant or coefficient. But here we have r, which we can differentiate. They are multiplied and divided with it, so they are in the same term. So these won't be constant, this would be coefficient. What do we do with coefficient? Take coefficient out, take the derivative of the inside real function, then multiply it with the coefficient. So here a square, so what do we have here? A square by I raised to I theta, a square by e raised to I theta. So what do we have here is 1 by r. 1 by r, right, is in the same place, right? I told you numerator into numerator by denominator into denominator is fraction 1 into fraction 2. So here, so this is 1 by r, nothing is there means 1 is there. So this is 1 by r, like come on, it is in denominator, come on bro. So it is multiplied like this. So it was numerator into denominator, denominator into denominator, numerator into numerator, numerator nothing was there, so 1 was there, and denominator r and e theta were multiplied, so we separated them by multiplication. Now I can write this 1 by r as r raised to minus 1, because 1 by r is 1 by r raised to 1. If I write this as r raised to minus 1, then what happens is, this says how many times I multiplied it. Power. I just put opposite negative sign in this. Minus sign, opposite sign. So, opposite sign. Opposite sign. So, opposite sign means opposite of multiplication, which is division. Okay. So I just brought this denominator into numerator, opposite of numerator. So I brought denominator to numerator. Now I can balance that by putting opposite sign in the raise to. So opposite balance. I can put opposite sign, that is minus, then it would be balanced. Since it is divided by r, and r tells how many times we multiplied it, so I want to put it in multiplication. So if I put opposite sign, this is divided by r, so that divided by r will still show by opposite sign of minus, because if minus I put, this means opposite sign. So power says how many times we multiply. So if power is in minus, then it shows opposite of multiplication, which is division. So how many times it is divided. So our original thing was how many times it was divided. It was divided. So when we multiplied it and put opposite sign minus in raised to, then it means the same thing, right? So let's go. So what we do is r raised to minus 1. Now I take derivative of this. Derivative of this, nx raised to n minus 1 formula, d raised to dx, d by dx of x raised to n. Okay. So now what happens is x raised to n. So here r raised to minus 1. What is x? N is the raised to thing of x. So here minus 1 is raised to thing of r. So minus 1 is here n if we compare there. And so what did happen there? Nx raised to n minus 1. Okay. So this raised to thing became coefficient, minus 1 here. And this raised to thing is reduced by 1. Nx raised to n minus 1 happened, right? So now what we do is, minus goes outside and 1 minus 1 becomes 0, and so this becomes 1, so it is minus, so this is minus a square by e raised to a minus I theta. Now del v by del theta we have to do, which is a square by r e raised to I theta. So now theta term we have to prioritize. Like I told you, theta here it was theta only gets differentiated, others are constant if alone and coefficient if multiplied with theta terms, so or divided with theta terms. So a and r are different from theta, so but they can be constant or coefficient, but they are not alone, so not constant, and they are coefficient because they are multiplied with e raised to I theta. E raised to I theta is the theta term because there is theta. So this theta term. Now what we do is here. Hmm. Now what we do is here. When did I raised to minus I theta came up? I don't know. Did I do that here too? Oh my god, I don't know how. But yeah. Now what would happen is here. Hmm. Did I do something here? How did minus I theta came up? Nah, bro. No chance, bro. Nah. I would have made a mistake. Okay. So what we do is here a square by r. So what do we do with coefficient? Take coefficient out, take derivative of function, and multiply by coefficient later. A square by r out, e raised to minus I theta thing. Okay. Why e raised to minus I theta? Because it is in division. 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 If I multiply it, I have to balance that by putting opposite sign in the raised to, because the raised to shows how many times it's multiplied. Now I put minus sign, so now it says how many times it's divided, like opposite of multiplication is division. So I put opposite sign minus, so it says that. Now, so how many times it's divided, so it is balanced because it says opposite thing from before, now which was divided. Now we can multiply, and we did opposite stuff, but now we that indicated that opposite in like raised to by putting minus opposite sign. Now it itself raised to is saying like how many times it's divided, because raised to is how many times multiplied, and we put minus sign, so it is opposite, so opposite of multiplication division. So now it says how many times it is divided now, so it indicates there in raised to power only. So I don't need to put it in division now. It could be in multiplication now, and the thing would be still be done. Yo, one person came up to the stream. Thanks, bro. Thanks for coming. Welcome to the stream. Thanks for joining. What's up? Come up in the chat section, bro. We can interact, man. You can ask something like whatever you have doubt or something. Okay, he left. Thanks for visiting. Bye. Like like, share, subscribe, and also have a nice day. So yeah, it is to I theta. Now what do we do here? Here is a square by r and e raised to I theta. I told you. I told you. E raised to I theta is a double function, nested function, double layer function. E is a separate function of I theta, not theta. And I theta is a function of theta. So we need theta function. But it is double layered covered. Okay, so then we use chain like chain formula, something L hospital rule or something, something it is called. Okay, chain rule. Yeah, we use chain rule. Now how chain is, like we break it smaller, we join it. Okay, so first we take derivative as it is, then we take derivative of inside function and multiply with the previous derivative. Okay, so now what we do here is we take derivative of e raised to minus I theta. So e raised to derivative of e raised to x is e raised to x. It remains same. So e raised to minus I theta. Now I have to take derivative of minus I theta. Minus I theta derivative would be minus I is constant out, and del theta by del theta, it is 1 because, let me show you, theta raised to 1. 1 came up here because nx raised to n minus 1 rule. What is raised to here? N. What is raised to here? 1. So we would do whatever n is happening here. So x is same, n is only getting changed, so we change n only. So what is happening here, that n comes in coefficient and reduces itself by 1. So we put a 1 in coefficient and reduce itself by 1. So 1 minus 1 is 0. Anything raised to 0 is 1. So this is 1. So 1 into 1 is 1. So here we go 1. Now 1 into this, whatever this is, yeah, So this was del by del theta, right? So minus so it was minus I. So we took this coefficient to out, right? Minus I. This is constant, so there is coefficient because this constant is multiplied by the theta term. So it is coefficient. We took out that coefficient and took derivative of theta by theta. It became 1. Then we multiplied this to minus I. It anything multiplied by the 1 is that itself. So it is minus I, and this is multiplied by minus I. So it is minus I. Minus I square by r e raised to minus I theta. So now we have it all. Del v by del theta is this, okay? Wait a second. So now what I should do is not zoom out, okay? You have to take screenshot and notes. Okay, take screenshot and is it visible? Taking screenshot. Is it visible? Take screenshot, take notes. Now I'm erasing it so that we can put this in this Cauchy-Riemann equation and we can compare is it analytic, because that's only what we had to find after finding v and z, f of z. Yeah, so let's go ahead. Okay, wait a second, let me erase this. Okay, oh, it's gonna be a tough time for us. So z equal to r e raised to I theta in polar form and z equal to x plus iy in Cartesian form. This I had to say you. Okay, these both are equal. Okay, x plus iy. Okay, imaginary form, real part, magnitude and direction. Simple, right? So now erase this, whoosh. Some part is erased right now. Now to use this, what do we have here is del. My internet was cut, bro. Did you miss anything? If you missed, I'm really sorry, bro. I hope you haven't missed anything, bro, for real. So del u by del r. Do we have del u by del r? Yes. E raised to I theta. Super simple one. E raised to I theta. Now it should be equal to, is it equal to 1 by r del v by del theta? Del v by del theta we found. Yeah, this is this something long stuff. Okay, this is gonna be wrong, I guess. Minus I a square by r e raised to minus I theta. Minus I a square by r e raised to minus I theta doesn't look like equal anyways. Anyhow, I try to look it. But yeah, whatever. Del u by del theta is I r e raised to I theta. I r e raised to I theta, not minus I theta. I theta. We swapped the put opposite things to each other because r is first. R is first variable in function u and v, and u is first function in f of z. So first function u and r are related, but we swapped them and put u with theta, which is related to v actually, and v we put r, which was related to u. So we compensated with reversing the fraction of r and putting minus sign instead of plus, which was opposite. Okay. Minus r raised so this was del u by del theta, and now we need minus r is equal to minus r. Now it should be del v by del r. Did we find del v by del r? It was okay. I don't even understand it, what it is. Okay, what is going on here? Let's say this is mine. This was taken out. R raised to minus 1, r raised to minus 1, then minus r raised to minus 2. minus r raised to minus 2 minus a square. Okay, it should be my into minus a square by e. Okay, wait a second. Why e raised to minus I theta, bro? I don't understand. Okay, e raised to I theta. So into r square. So this is how it's supposed to be looking like. Okay, I guess so, but it's not looking like that anyways. So this minus into minus should be plus, and this r square is supposed to cut with this r square. This r is supposed to be cut with r square because r square is r into r. So if you have opposite side same number dividing, it would cancel. Opposite, there is war and they defeat each other. Same power, Pokemon card stuff. So a square by e raised to I theta into r. Does it somewhere look like this? So is this even analytic? So what were we doing? Wasting time? I don't think so. We solved the question. Please, if anyone is there, please check if this is right. Wait a second. What just happened right now? I don't even know. Okay. So yeah, I'm zooming out. Take screenshot. Take notes. I suppose. Take screenshot. Take notes. Let me zoom out. Take screenshot. Take notes. And here we are done with the question. Wrongly. Do solving it wrong. So thanks for staying by, whoever came and watched. Thanks for watching. Like, share, subscribe. See you next time. Peace out. Bye. Even my internet is saying bye. So bye.